In this video, we're going to go over how to do a hypothesis test for two means which are matched pairs. So this question says, listed below are the numbers of words spoken in a day by each member of 8 different randomly selected couples. Complete parts A and B below. So here you can see we have the number of words that different men spoke in a day, and then different numbers of words that women spoke in a day. And what's important to note here is that these are from 8 different couples. So that means that these two numbers here in this column, those numbers are paired together because this man and this woman are a couple. This man and this woman are a couple. So the numbers from the first row and the second row are each paired together in a way that makes sense. Use a 0.01 significance level to test the claim that among couples, males speak fewer words in a day than females. Then they're telling us that in this example, mu d, that means the difference in the means, is the mean value of the differences d for the population of all pairs of data, where each individual difference d is defined as the words spoken by the male minus the words spoken by the female. What are the null and alternative hypotheses for this hypothesis test? So that was very wordy, but basically what we're doing here is we're gonna, instead of looking at these men as if they're one sample and these women as if they're a totally different sample, we're going to actually take the differences in the number of words that they spoke and figure out if that difference is meaningful or not. So what they're telling us here when they say D is defined as the word spoken by the male minus the word spoken by the female, that's important because it tells us in what order we are going to subtract these numbers. So what we're going to do basically is we're going to take the male numbers here, and from that we're going to subtract the female numbers. Okay? So then let's see what that means. Well, if we take the male numbers and we subtract from it the female numbers, and we're also saying in our hypothesis that males speak fewer words than females, then what would that difference look like? If the number for the male is smaller than the number for the female, and if we're subtracting in this order males minus females, well, if I take a smaller number and I subtract from it a bigger number, then I'm going to get something negative, right? I'm going to get a result that's less than 0. So that is what symbolically our hypothesis or our claim is going to be here, that the differences, the mean of the differences is less than 0. Since that less than sign is implied in our claim, this statement is going to go in our alternative hypothesis. So in the alternative hypothesis here, we're going to choose less than 0. Again, that's just a symbolic way to say that when I subtract male words minus female words, I would get a number that's less than 0 because we're hypothesizing, we're claiming that men speak fewer words than women. Remember, the null hypothesis always has an equal sign in it, so we should know automatically that we should pick an equals here, and this number here will also be 0. The numbers here and here should always be the same. Okay, so now we need to find the test statistics. So we're going to do this using Statcrunch. First, we want to open the data in Statcrunch. We can do that by clicking on the little blue icon next to the data table and selecting Open in Statcrunch. So we're going to go ahead and do our hypothesis test here. Remember, all the hypothesis tests are going to be under this stat drop-down. And for this one, we're going to choose T-stats. We're choosing T-stats because we're talking about a hypothesis test for a mean, and we do not know the standard deviation from the whole population. We have a sample, so we can get the standard deviation from the sample, but it's important to note where the standard deviation comes from. If it's from a population, we would use a different test, but that's very unlikely. If it's from a sample, which is most of the time, we're going to use a t-test and select t-stats here. And for this one, we're going to choose paired. We do have 2 samples here, so it's tempting to choose 2 sample, but this is when the 2 samples are independent. Our samples were paired. Remember, they were from couples, so every male number was paired with a female number for their partner in that relationship. So we're going to choose paired here. So in column, the sample for the first one is going to be the males. The sample for the second group is the females, right? And remember, we said that we were doing males minus females is less than 0. So down here we're going to say perform a hypothesis test, and that the difference here is less than 0. Click compute. So now we have our test statistic right here under t-stat. So we're going to go ahead and copy this and paste it over into the answer field. This says to round to 2 decimal places, so after the decimal point we're going to go 1, 2, where we wind up at that 0. We look 1 digit further to the right and see a 6. That means we round up, so we're going to change that 0 to a 1. Next we need the p-value. The p-value was right next to that. Going to be right here. Copy that. Paste. This is round to 3 decimal places, so after the decimal point we go 1, 2, 3 places, we wind up at that 4. We look after the 4 and see a 1, which means we round down, so that 4 is going to stay at 4. So now we need to make a conclusion. First we need to decide if we are going to reject or if we are going to fail to reject the null hypothesis. And the way we do that is by looking at the p-value and comparing it to our significance level. The rule is if the p-value is less than the significance level, then we will reject the null hypothesis, reject H0. If the p-value is greater than the significance level, then we will fail to reject the null hypothesis, H0. In this case, our p-value was 0.314, and our significance level was 0.01. So that p-value is definitely bigger than the significance level. So that means we are going to fail to reject the null hypothesis. So here it says since the p-value is greater than the significance level, we will fail to reject the null hypothesis. Okay, so what does that mean practically? Well, this was our null hypothesis. The null hypothesis said that the difference was going to be 0. In other words, there's no difference. The difference is 0 between the men and the women, so men are speaking the same number of words as women. And we did not decide to reject that. So in other words, we're saying, yeah, it could be, I don't know. There's no reason I would reject that statement. I don't have any evidence to reject it. So what I like to do is just circle that statement indicating, hey, I didn't reject this. As far as I'm concerned, it might be true. Well, if we're accepting that that statement might be true, then we have to basically reject the other statement. I can't accept both at the same time. So I like to cross out the other statement to indicate visually to myself that I am rejecting that statement. But remember the alternative hypothesis here that we just crossed out, that was the claim. The claim said that the men spoke fewer words than the women. So when I've crossed that out, I have basically not supported that claim. So we would say here, there is not sufficient evidence to support the claim that males speak fewer words in a day than females. Next, we need to do a confidence interval, and we can go right back to Statcrunch, and you can either start over, or if you still have this open, you can go to Options and then say Edit. So again, in sample 1 we had the males and sample 2 the females. The nice thing about saying the edit is that you can just go back in and all of what you had prior should be saved. But if not, you can just go back through and redo what you just did. But this time we're going to do a confidence interval instead of a hypothesis test. So we'll just click this little button here next to confidence interval. So now we need to decide what the confidence level is. The way we figure that out is as follows. First, we need to know if we have a one-tailed or a two-tailed hypothesis test in the first place. A confidence interval is always two-tailed. We have a section in the middle, which is our confidence area, and then we have two tails on the end, one on the right and one on the left. If our hypothesis was already two-tailed, then all we need to do to find the confidence level is take the complement of the significance level. Remember, the complement just means we subtract the significance level from 1. In this case, though, we had a one-tailed test. In fact, we had a left-tailed test. We know we had a left-tailed test because if we look at that symbol in the alternative hypothesis, we see a less than symbol. It kind of looks like an arrow pointing to the left. So that tells us that it's a left-tailed test. A one-tailed test, the way to find the confidence level is you're going to first take the significance level and multiply it by 2. That's basically just going from having only one tail to now having two tails. And then from that new number, you're going to subtract that from 1 to get the confidence level. So here we had a one-tailed test and our significance level was 0.01. So first we're going to take that 0.01 multiply it by 2, and then we're going to take that and subtract it from 1. So 1 minus 0.02 is going to be 0.98. So that's our confidence level. And we click compute. And now here we have the lower limit and the upper limit for our confidence interval. So we're going to go ahead and copy those and paste them over into the answer field. This says round to the nearest integer, so we don't even want decimals at this point. So the nearest integer we have here a 9. After the 9 comes a 5, which means we're going to round that 9 up. Well, the 9 actually rounds up to a 10, which means this 69 is actually going to round up to a 70. 70. And the upper limit is here, which we copy and paste. So the nearest, the whole number digit is a 6. We look after that, we see a 3, which means we round down, so we're going to leave that 6 as a 6. So now we'd like to interpret that confidence interval. What feature of the confidence interval leads to the same conclusion reached in part A? Well, remember, in part A, we decided that we did not have evidence to support the claim that the men spoke fewer words than women. If we look back up here, we rejected this statement and we did not reject this statement. So this statement said that the differences were equal to 0. So we're saying, okay, I think it's possible that the differences are equal to 0. So we should be looking then in our confidence interval to see if 0 is contained in the interval. And in this case it is. The lower limit here is a negative number, negative 12,000. And the upper limit is a positive number, positive 8,000. So 0 is definitely between those two numbers. So I think that the mean of the differences could be anywhere between this number and this number, 0 included. Since 0 is included inside those limits, then I have to assume that the mean of the differences could be 0, which means again that the males and the females' words spoken were the same. So since the confidence interval contains 0, we would fail to reject the null hypothesis, which said the same thing, that the differences were 0.